So, in this module of mechanics, today I will be talking of pseudo forces. You know, Newton's laws are valid in inertial frames of reference. Inertial frame is one in which if you have no forces on a particle, it remains at rest or it moves with a constant velocity. And if the frame is inertial, then you can use Newton's second law, force is mass times acceleration. Our frame of earth is approximately inertial. So, for if not so sophisticated calculations are required, we use F equal to m times a. But if a frame is accelerated with respect to an inertial frame, for our purpose, with respect to our laboratory, with respect to our roads, with respect to our ponds, railway stations, if something is accelerating and the frame is made in that accelerating object, then it is a non-inertial frame. If it is non-inertial frame, F equal to ma will not work. So, that means if you write mass times acceleration for a non-inertial frame, mass times acceleration is not equal to the total force applied on the particle, is not equal to this, and therefore, if it is not equal to this, you should have something else. This ma minus f, which is not 0, call that this f, or rather let me write it fp. P is for pseudo. So, mass times acceleration is not equal to the total forces applied. So, this force is the resultant force or resultant of all the forces applied on the particle and if this frame is non-inertial, resultant of all the forces applied on the particle is not same as mass times acceleration. So, ma minus f will not be 0, and that we are writing is fp. And this extra term which is coming because of this non-inertial frame is known as pseudo force. And if you use this pseudo force, if you know what this Fp is, and if you add this term to the resultant of all the forces applied on the particle, then it looks like mass times acceleration is this total force, and you can use all the techniques of inertial frames here. So, that is about that is the introduction. Now, the frame can be non-inertial in many ways. It can have a linear acceleration with respect to inertial frame. So, it is moving in a particular direction and the frame is accelerated, its velocity is changing. Linear acceleration with respect to an inertial frame, or the frame itself can rotate with respect to an inertial frame. In these situations, you have different kinds of pseudo forces resulting. Today, we will be talking of frames which are linearly accelerated, which are moving in a certain direction with respect to an inertial frame, but that movement velocity is changing with time. So, in that case, what are the pseudo forces required? So, we will do some experiments and then come back to this board. So, our first experiment is, I have this plastic box and some particles are there. In fact, these are pulses, very rare commodity nowadays, and is spread over this bottom, everywhere on this bottom. I am keeping it here. So, the box will be our frame, and these particles which are there inside at the bottom, focus on that. What I will be doing, I will accelerate the box in certain direction, and if I accelerate the box, then you see what happens. At present, this is inertial frame of reference. There are no resultant force, there is no resultant force on these particles. The weight is being balanced by the normal reaction force from the bottom, and all these particles are at rest. See what happens if this box is accelerated. So, with respect to box, with respect to this accelerated frame, what happens to these particles? Still the gravity is there and the normal force is there. Friction will also be there. At present it is 0, some friction will be there, but the pseudo forces will dominate. So, look at this. So, what have you seen? What did I do? What kind of motion I gave to the box? I took it towards in one direction. That means I accelerated it in this direction, but then I also stopped it after some time. That means during this motion, first it was accelerated and then it was decelerated. In other words, in the first part, the acceleration was in one direction, and then it is in the opposite direction. So, what happened to these particles in the first part? They all went opposite to the acceleration. With respect to me, the acceleration was towards left and the particles were going towards right. You can see it again. So, when the acceleration is towards left, the particles with respect to box are going towards right. That means the pseudo force is opposite to the acceleration of the frame. And what happened in the second part? In the second part, when I was stopping it, that means decelerating, acceleration was in towards right with respect to me. And what had happened to these particles? They went towards left. First they went towards right and then they went towards left. Once again the motion was in the direction opposite to the acceleration of the frame. Acceleration was towards right with respect to me and these particles went towards left with respect to the box as seen by me. Okay? Okay, so let us understand it from the equations. So, suppose you neglect the friction. In that case, the forces, real forces which are applied on these particles are only in vertical direction, the weight downward and the normal reaction force from the bottom upwards. So, in horizontal direction, the resultant applied force is 0, and so with respect to my room, with respect to this table, these particles are at rest, should be at rest. And the box is taken with an acceleration say a0 in certain direction. Since these particles are at rest in the lab frame and in the same lab frame the box is going with an acceleration a0, so the acceleration of these particles from the box will be minus a0. And so, if you look at these this equation, the applied force, real applied force is 0, resultant is 0 in horizontal direction. In fact, if you neglect friction, there is nothing, and therefore this pseudo force is just this mass into acceleration, this is the acceleration of the particle with respect to that box, which is minus a naught, if a naught is the acceleration of the box with respect to the lab. So, if I say that a naught is the acceleration of the frame, of the non-inertial frame, with respect to the lab or table or room, inertial frame, assumed inertial frame, if this is a naught, then this pseudo force will be, pseudo force on the particle will be minus m into a naught, because this acceleration of the particle from the box is minus a naught, and so the pseudo force will be minus m a naught. Look at the structure. This is mass of the particle, and this is acceleration of the frame. So, this is an artificial kind of structure, mathematical quantity. You take mass of the particle and acceleration of the box and then multiply and put a minus sign. So, that is the pseudo force. So, for linear acceleration of the frame, it is very simple. You take the mass of the particle, multiply it by the acceleration of the frame with respect to inertial frame, put a minus sign, that means you reverse the direction, and that is the pseudo force on that particle. We will do some more experiments to see this effect. It is the same idea. Here you have water in this vessel, and in the water we have put a ball which is heavier than water, density is more, and it is suspended with the help of this thread fixed, one end of the thread is fixed on this lid. So, if you look at the ball right now, this ball is in equilibrium in the lab frame of reference. Box is also at rest in this lab. The total force on the ball is 0. What are the forces? Its weight, buoyancy by the liquid, and tension of this thread, and all these add to 0. So, now I will accelerate the box, and with respect to the box, you see what happens to this ball, which direction it moves. So, look at it. So, once again you see that when I start accelerating, the ball goes in the opposite direction. I accelerate the box in the towards left with respect to myself, and this ball goes towards right with respect to this box as seen by me. Same explanation. First, in fact, I accelerate, the direction of the acceleration of the box is towards left, and later on when the box stops, in that part the acceleration is opposite, and hence the pseudo force in the first part it is towards right as seen by me, and then towards left in the second part when the acceleration reverses. Okay, so now another version of this experiment. In this you have water in this vessel, and a tennis ball is, you can see a tennis ball, and it is fastened to the bottom through a string. So, since it wants to float and we have forcefully kept it there, string is tight, there is some tension in the string. Then on this ball you have buoyancy force upward and its weight. and buoyancy force is more, weight is less, and therefore tension is needed. Weight plus tension is equal to buoyancy force, and it is in equilibrium. Net force is 0 and there is no acceleration. This is inertial frame of reference. Now, as I did before, I will take this whole thing in one direction, accelerate it, and then pseudo force will act. Accordingly, the ball will get displaced. So, watch out, I am displacing it. So, which direction did the ball deflect to start with? When I accelerated it towards left with respect to myself, which direction did the ball go? It goes in the direction of the acceleration of this frame. Once again, this time all resultant force 0, buoyancy, tension, weight, total force is 0. I am using inertial frame. This box itself is in inertial frame, tub is inertial frame, table is inertial frame. So, total force is 0, total acceleration of the ball is 0. Now, the frame will be accelerated towards left, and you see what happens. The ball also goes in the same direction. So, what happened? If the frame is accelerated towards left, the pseudo force that I have to add, the extra force on top of the real forces that I have to add, is minus m into a naught, should be opposite to the direction of the acceleration of the frame, and that means with respect to me it should be in towards right, but the ball is going towards left. So, what went wrong? So, you have to think over it, and it will be one of your homework problems. Okay, now one more experiment in this session, and for that I have a plastic box, and in this plastic box I will be putting this ring magnet. Then in the lid of this plastic box I have already fixed another ring magnet here. It is attached to the lid using this double sided sticky tape. So, the other magnet I am putting in this box. So, now one magnet is here in the box and the other magnet is here, and I screw the box. So, box will be our frame, and at this moment the box is stationary, this frame is inertial, and focus on the forces on this lower magnet. So, what are the forces? The forces are its own weight, then normal reaction force due to this bottom, and the upper magnet is attracting it. I have put the polarities in such a way that the upper magnet is attracting, but the force of attraction by the upper magnet is small as compared to the weight, and therefore, it is just staying here. The normal force plus that attraction force is balanced by this weight, total force is 0, total acceleration is 0. Now, I will just drop it so that this box will start falling with an acceleration g downward. So, this will become non-inertial frame. So, with respect to that box, you will have to apply appropriate pseudo forces to discuss the motion of this ring magnet with respect to the box. So, see what happens. I am just dropping it. So, where has the magnet gone? it's not here. The magnet has gone to this lid and it gets stuck to this upper magnet. So let me repeat this experiment once more and then we will do the dynamics. So now the magnet is here at the bottom, one magnet is at the lid, and I am dropping this box. So what did you see? The magnet which was here with respect to box went up and then it gets stuck to this upper magnet. It's a fast process, you may not be able to see the magnet going up, but when the magnet goes up and strikes this other magnet, it makes a sound, and that sound you cannot miss. So let us see how do we analyze it using our equations. So we have this box which is our frame. In this box we have this magnet, ring magnet here, call it A, call this magnet A. I have another magnet here. To start with, everything is stationary and then the box is allowed to fall. So in the inertial frame, the box is going with a acceleration g here. You can take the upward direction as z direction, so that the unit vector in this direction will be written as k cap. And now I will analyze this from the box frame. So forces on the magnet A. What are the forces? Weight mg, which is in downward direction, we have taken z direction upward, so minus k cap. So this is the weight, this is weight. Then I have normal reaction force from this bottom. That force will be in upward direction, so you can write that as N, and this is in upward direction. Then attraction because of this magnet, attraction because of this magnet, so that is force, magnetic force, and that is also upward, so k cap. These are the real forces. This one is weight, this one is normal force due to the bottom, and then this is the magnetic attraction force. Due to the upper magnet. And since we are using non-inertial frame, I must apply a pseudo force also. I must write a pseudo force also on this A, and that pseudo force will be mass of this magnet, the object, and multiplied by acceleration of the frame with a minus sign. So it is minus mass of the magnet, and acceleration of the box is g in downward direction. So it is g and k cap, right. So acceleration is in downward direction, and this force, this pseudo force that I am writing, is in upward direction, so plus mgk. So this is the pseudo force. that I will have to include because I am using this non-inertial frame. The frame is accelerated downward and therefore the pseudo force has to be up. Mass into mass of the object into acceleration of the frame and in opposite direction. So, frame is accelerating down, the pseudo force is up. So, this is the total force on this, and that should become mass times acceleration. This acceleration is acceleration of this object with respect to our falling box frame. Now, you can see that the pseudo force in this case cancels with the weight, and then you have only these forces, normal force and magnetic force, and both are upward, and therefore this magnet should go up, it should accelerate in upward direction, and as it goes slightly up, this contact here is broken and then this n also becomes 0. So, it moves only under this magnetic attraction, and that is in upward direction. So, in the box frame it has to go up, and it goes up and strikes this upper magnet. So, this is how pseudo forces are included. And if your frame is falling freely or it has an acceleration g, as you see here, all effects of gravity gets cancelled with the pseudo force. So, the pseudo force and this weight, they all cancel each other. So, you forget pseudo force and you forget gravity, and you can write your equations and it works. So, this is also known as weightlessness. The weight, the effect of gravity is taken care of by this pseudo force, and therefore you can conveniently, comfortably forget gravity, think it as weightless, and also do not use any pseudo force, and still you analyze and get the motion correctly in this freely falling frame.